Question 11. They tell us we've got a regular pentagon and a regular hexagon, and they are equivalent. So if they're equivalent, it means that their areas of area A equals area B. Given that they're equivalent, the areas are the same, we're asked to identify which of them would have the smallest perimeter. Well, our rule tells us that the more sides on a regular polygon you have, the smaller the perimeter. So in this case, the smallest perimeter would be the hexagon. Now, if you relate it back to my improvisational rule to which one is closest to a circle, then clearly the hexagon is closest to having a circular shape. So the hexagon has the smallest perimeter. Question 12. Again, we've got a regular pentagon this time and a regular hexagon with the same perimeter. So the distance around each shape is exactly the same. So again, this is where you can think about if you had a string and that was tied in a circle and you formed it into each of these shapes, we're asked to find which one has the greatest area. So we're maximizing the area. Is it going to be A or B? So the more sides you have, the greater the area that's going to be enclosed if the perimeter is fixed. So the more sides it has, the closer it comes to approaching the shape of a circle, so that shape is going to give you the maximum. So again, using that improvisational rule of which one is most similar to a circle, the hexagon is closest to resembling a circle, so we can say therefore the maximum area would be the hexagon. Question 13. What is the maximum area of a rectangle with a perimeter of 16 centimeters? Again, using my improvisational rule of saying which one comes closest to a circle or what shape is closest to a circle, a rectangle that is closest to being like a circle is in fact a square. So by knowing that you're going to maximize the area by having a square, then it's just a matter of figuring out what's the side length you would have for a square that has the same area as this rectangle. If the perimeter is 16 centimeters, we know that the perimeter of a square is equal to 4 times the side length. So that means that 16 is equal to 4 times the side length. So each side is going to be equal to 4 units, or 4 centimeters, I guess, in this case. Question 14. What is the maximum area to the nearest hundredth of a triangle with a perimeter of 12 centimeters? Again, think in terms of which triangle shape is closest to resembling a circle. If we go back to our previous question where we had the different triangle shapes, the one that we identified as being closest to resembling a circle was the equilateral triangle. That tells us that to maximize the area of a triangle, we're going to want an equilateral triangle. That means that it has 3 sides equal. If the perimeter is equal to 12 centimeters, then each side, S, is going to be 12 divided by 3, which of course is 4. Once we've got the side length, we can then go ahead and figure out the height of the triangle, which we're going to need in order to calculate the area. Remember, area is equal to half the base times the height, or base times height divided by 2. We've got the base now because we know it's one of the sides S. We know we want to maximize the area, and we need the height. So let's go ahead and figure out what the height is. Height is equal to the square root of the side squared minus 1/2 the side squared, which is equal to the square root of 4 squared minus 1/2 times 4, all of that squared. That's equal to 16. 1/2 times 4 is 2, squared is 4. So we end up with h is equal to the square root of 12, which we can do on our calculator, and we come up to 3.5 centimeters. Or, if you're keeping some more decimal places, 3.46 I think is what they asked us to keep track of. Now that we've got the height and the side, we can go ahead and calculate the area. 1/2 times the base, which is 4, times the height, which is 3.46. Multiplying that out, you end up with 6.92. So therefore, the maximum area of a triangle with a perimeter of 12 is 6.92 square centimeters.